Hey everyone, this is going to be on my 356 horns. Hopefully it's going to be the final assembly. I made a video a couple weeks ago about these horns. I wasn't sure they were going to work at all, but I was able to get them to work. So now I've gone through a cosmetic restoration, painted a few things, got a few things plated. So now it should be time just to reassemble everything together. Got some new gaskets, original screws, which are actually Cerakoted. This piece here is also Cerakoted. Everything else has been painted and sanded, and a lot of detail went into getting all the pits out of these horn grills because my car has had a hard life. Epoxy primer. So even though this is straight, it's not ready to go on the car. This has to be filled and sanded before I'm happy with it. Some filler, some sanding, some more epoxy primer, and then top coated with a Rust-Oleum mix that I like. I also got some other nameplates that are more accurate. So this is the reproduction. It's pretty close. I mean, there are some differences in the font and so forth, but it is close enough. I also made these gaskets with my laser cutter. So this is DIY as well. The internals of these were also heavily pitted, so I did my best to selectively sandblast or spot blast and then repaint. I just repainted the whole interior, trying to prevent rust. So I think we got it. I also 3D printed this terminal block. Remember the one on one of the horns was broken last time? If you remembered, I had to weld on some of the screws. So I ended up sourcing another horn, a cheaper horn on eBay from a Volvo. It's a lot smaller and so forth, but I robbed some screws from that horn to restore my original screws. The screws that come with the restoration kit are quite a bit different in shape, so plus they're not black. So if I'm gonna go through the trouble of painting them, I wanted to restore the originals if I can. Staying organized is tough when all these parts have to get bagged up and go to the plater. So I need to reassemble these in the correct order, and to do that, I just have a bunch of pictures. So I'm gonna try to show the order in which all this goes back together. Spindle, this plate here, there's a little washer with a cone on it that goes on the far side of that. This goes inside here. There's a gasket, the diaphragm, another gasket. There's a rubber donut here. There's this guy with the pin that's pressed in. This is an extra plate that I think controls the tone. And then there's a big heavy washer, a spring washer, and then the nut. This boss fits right inside there. And then this conical washer will go on just like that. Now this piece threads inside here. Now it'll go two different directions, so let me check my pictures. I'm just gonna put a tiny drop or just a tiny bit of anti-seize on this because this was really hard to get apart. The hollow part of that internal section, the threaded section, goes towards the side that has the dish. So it's a little bit more flush on this side. The dish side goes towards the diaphragm, and then this whole thing will go like so. That locks into the little stakes. And then we'll need to get that pin lined up. So another washer on this side. There's a little, I didn't get a new one of these or make a new one of these. This is like a flat O-ring or a rubber washer. It goes in that little recess and then this points down over that. So we can go ahead and put that on here. And then now we should be able to put this through and line up all the pieces. Next is this plate. Like so. And then a washer, spring washer, and a nut. There should be some clearance between these two plates. They don't need to touch. Also, you should not be able to rotate this more than just a few degrees. It is locked in by that pin. So that's on purpose because that's part of the adjustment. When you adjust this nut, it drives this in or out. So it interacts with this part of the coil. When I turn the screw clockwise, it pushes this plate out. So I can put my screwdriver between that plate and that big spacer. If I turn it counterclockwise, it sucks that plate in. So now there's no room for the screwdriver to go in. So this is controlling this plate relative to this diaphragm, and that is an important adjustment. So that is the assembly for that. Let's put this aside and then do the other one. Now, an interesting thing about this one, the construction is really similar, but this plate, instead of being like a disc like this one, it's got a chamfer to it, but this one is a cupped plate. And I might have a replacement horn that's not correct. I am not sure. When I disassembled these and painted them, I did notice that there's a date code on these, and this one has a date code of 12U. That is like, I have to look it up on the Bosch date codes, but 12U corresponds to 1963. My car is early 64. And a little bit of research that I had done shows that the C's had this kind of shape. So why I have a mismatch, I am not sure. I had this car since the 90s and the horns never worked. Partially because it was converted to 12 volts and I think it was done poorly, and partly because, you know, there was broken terminal blocks and a lot of rust inside and so forth. So it is possible that prior to me getting the car, one of the horns got replaced. I just don't know. So I'm gonna go ahead and run these horns as is. If any of you know more about the numbers on the back and what would be possible for mine's like an early 64, you know, let me know. The interesting thing I noticed on the back is this horn says H06A 7106. The other horn says H09 7109. When I look those numbers up, this corresponds to a Porsche or Bosch horn part number. The 09 and 7109 doesn't show up like it exists at all. So when I typed it in, it said on just Google, you know, it said this is likely a typo. But mine is clearly stamped 9 instead of 6. So one possibility is that the internet's wrong. The other possibility is that mine was stamped upside down. A 6 and a 9 could very well be a mistake by Bosch. So I don't know if anyone of you have any feedback on what might be possible on that one. You know, let me know. Next up are these terminal blocks, and I cleaned them up on my wire wheel, and I'm just checking that the threads are good. And I'm also, you know, blowing out the hole, making sure that the wire cavity is fully open. So this thing is ready to go. We'll check. I have 4 of them here, so we'll just make sure all the threads are good. Okay, my soldering station is cranked up to max temperature, 850 degrees. It's kind of light duty for something that's this heavy, but we take our time. We keep the tip nice and clean. I also have some flux, which tends to clean it a little bit more. So I just put a little bit on the toothpick. Just touch the top there. So I've been able to clean this well enough so the whole surface is wetted. So it's nice and pre-tinned. I should have no problem soldering this once it's installed. So these guys are cleaned and prepped, ready to go. They get a rubber gasket. So this thing fits inside the terminal block, actually like this. So this rubber gasket is important so water doesn't get inside the horn again. I'm gonna go ahead and place this through the body of the horn and leave the terminal block off for now. Go ahead and solder it, and then we'll just slip the terminal block over this hot brass. I don't want to melt the terminal block. I've done the same thing with the wire. I've pre-tinned it, so when this thing comes through the body of the horn, I can just solder it right on there. Oh, dropped it. I outsmarted that one because these were falling down due to gravity and just the heat, plus the solder iron pressure. So I put the screw in that holds the terminal block, but instead of the terminal block, I just put a washer. So that supports the weight of these things. So now I could go ahead and melt the solder in from the other side. Okay, so now that's finished. I'm gonna go ahead and put the paper gasket on. And then this plate has to contact these breaker points. That's important. So this has to go on just one way. So it looks like to me this hole where that pin goes through, that hole goes towards the terminal block. Now this could go multiple ways too. So for right now, I'm going to line it up with the terminal block. That's just arbitrary. I'll have to do some looking around to see exactly which way this goes. There were some marks on the actual horn bucket, but I didn't see any corresponding marks on the actual horn grill. Now the terminal block should go right over. I just need to rotate it slightly. And then there is a gasket that goes underneath the terminal block as well. So there's a little relief here in the terminal block, and that goes right where the screw hole goes. Like that. That is the terminal block installed. So we leave the nameplate off until we can finish adjusting it and check the tone to know which nameplate to put on there. This is the one that's marked 9 instead of 6. So it's kind of an oddball. I did these screw heads in Cerakote because they are very durable. A screwdriver is not gonna take the paint off. So even though they're slightly less shiny, they are very durable. These are 6-volt horns, so I'm using a 7.4 volt battery, which, you know, if the charging system's working, it's about 7.4. So right out of the gate, we're getting some noise. It's a little bit anemic, so we'll do some adjusting while it's working and see if we can just get it to the loudest possible sound. Okay, I didn't get a good tone out of that one, so I'm going to turn this screw in just half a turn and see what we get. Okay, I got this one adjusted, and the only trick I have for you is when you energize the horn and you see this adjustment or the diaphragm, when you see it moving like dramatically in, that means that the plate is just too far from the internal coil and it's having to suck it in too far, and it gives you that anemic sound. If you adjust this screw, and I was adjusting it counterclockwise, that moves that plate closer to the coil, so it doesn't have as far to move. So when you watch it really carefully, you can see that it just vibrates around its normal position. It doesn't suck in. So if you just watch that adjustment screw, you don't see any major movement in that screw. This is the second horn, and it's now working as well. So I have something on my phone which is a physics app, and it can measure the frequency. So I'm going to play it and measure the frequency at the same time. So this is telling me this first frequency is 257.8. I'm going to switch to the other horn and see what I get on that one. Getting an error on the app. It's telling me it's much higher. This one's in the 500 hertz range, but I'm not quite sure I believe that one. I was unable to get the exact frequency. I think one is 250 and one is 450, but that doesn't seem accurate to me. So, but I know this is the low tone, and the 15 is the low tone according to something on the registry. So I'm going to put this nameplate on this one and be done. So now they're complete. This has been a long battle of bringing these back. Remember, I had to use a lot of heat and weld to get the screws apart. The shaft was stuck. The terminal block was broken. So these have definitely come a long way. Pretty happy with that little project, even though it turned out to be not so little. One uncomfortable thing I have with these horns is that capacitor inside the horn itself. It's wired directly across those contacts that open and close really quickly. And originally I said it wrong. I thought that that was part of the circuit that created the frequency. And I thought it was really crucial for the function of the horn. But come to find out, a few of you pointed out that it's actually not part of the frequency. It's basically just there to protect the arcing that can occur over the contacts. When they open and close, you can get arcing across the points. And that's what that capacitor is for. But it does probably alter the sound just a little bit. Mine were destroyed, like barely functioning. So that's one thing that if I did it again, I would do differently. I think I'm going to order a capacitor that is the same value. And I also said previously it was 130 microfarads. I had read that wrong, or it was posted wrong on some website. It's actually a 1 microfarad capacitor, and the original is a paper wax type capacitor. They're no longer available. Modern capacitors can not handle the voltage swings and the polarity swings because it's DC voltage. So I need to find a special capacitor that I could make into the same form factor and try to plug it in. So I may do that on a different horn, or maybe take one of these apart again and see if it actually makes a difference. Because I'm getting a different volume level out of each, even though I've adjusted them to the sweet spot. They're actually, the low frequency horn is quite a bit lower volume than the high frequency horn. I don't know if it's due to the capacitor or not, so that's one thing that I might look into again. But for now, they're horns, they're good enough. These are visible from the exterior of the car. You can kind of look through the horn grill and you can see them. So that's why I went through a little bit extra work to sort of make them as presentable as possible. It's not super obvious to see them, but they are there. So anyhow, that's the horn restoration for my Porsche 356. hopefully we'll get them installed in the car soon. Hope to have the car back before the end of the year. All right, thanks for watching, and we'll see you guys next week. Cheers.